We're going to sit back and chill, do this pure 3 new specimen paper. We're going to do some of the questions from this. I've highlighted a few. Now look, do you want to be able to do this with ease? Do you want to stop stressing about your exam, not know where to study, what to study, how to study? There's no mystery to these exams. There's no mystery to this exam. I know what they're going to ask. I've done thousands of these questions. I know what these exam writers, I know what they're going to ask. I know how to answer all the questions. I know the exact methods to answer all the type of questions they can possibly ask. There's no mystery here. If you think you're bad at maths, if you think you're screwed, you're like, oh fuck, I'm screwed, I'm going to fail. You will not fail. You just need to watch my videos. Just watch my videos, man. You won't fail. I promise you. You'll pass very quickly. I can take you from thinking, oh my god, I'm going to fail this exam because I'm bad at maths, to I know what's going on here. I'm pretty confident here that I'm going to get a good grade in a matter of weeks. I can do that for you. There's no need to stress that you're not bad at math, okay? You just don't know you don't know the method and strategies to answering and doing well in math exams. It doesn't matter about the content. This is why I've been trying to drill into you guys with this whole fucking channel. It doesn't matter about the content. It matters about doing well in the exam. That's all they care about. That's what goes on paper. That's what stays with you forever, is the grade you get. You might know all this shit, but then you can't pass an exam, you can't do well in the exam room. It's for nothing. You get a bad grade, that's what sticks. So the exam method is the most important thing. And there's no mystery to this shit. We've got it done and dusted. It's predicted, man. It's done. So you have nothing to stress about. So grab that, man. I want thousands. I'm gonna keep going. I want thousands of you motherfuckers like acing this shit. Just coming through and realizing that it's not that hard. It's not that scary. It's not that bad. And you can do this for not just this exam, but the method that I implement will stick in your brain, and you'll continue to use it throughout all the exams you take in the future. This is just not like this is a big picture method. This is how we ace exams in whole. I'm teaching you the examination method through this one exam and through the others. Anyway, let's do some questions from this exam. All right, so I have highlighted a few of the ones I want to do. This is going to be a bit more laid back because I want to enjoy these kind of videos. I want to sit back, I want to talk a little bit, and also, do some questions. It's not going to be as serious as when I do my exam hack series, like when we're really getting into it. We're just going to sort of sit back. I got myself a beer. I'm going to drink this beer because I'm not your teacher, and I can sit here and I'm allowed to drink a beer while I teach you how to ace these things. Anyways, let's kick into it. So yeah, like I said, I highlighted a few of them. Just going to go through them, and I brought up the answer sheet as well, so we can check that we're doing them right. Because I haven't done these before, so I'm just doing this off the cuff to kind of test myself, and also just help you guys as well. So let's do these things. And for me, this is pretty easy at this point because I've analyzed the exam. Okay, so find the set of values of x for which this is satisfied. This inequality. Give your answer in the simplified exact form. Okay, so immediately I'm thinking logs. Immediately, as soon as I see this, I'm thinking logs, because I'm going to need logs to get this x's down from the exponent. So let's rewrite it. So we have this, and we want to solve this. So for what x values does this equation or inequality hold? Okay, well, the first thing I would immediately do is divide through by 3. Why do I do that? Because I can. Okay, 2 to the 3x plus 1 is then less than 8 over 3. So I just divided through by 3. Now I'll take the logs, the natural log of both sides, because this will help me get this exponent to come down, and then I can solve for x. So now I can take this 3x plus 1 down. This is ln of 2. And this just comes from your log rules. And then I'll get 3x plus 1, because I'm trying to get x is less than something or greater than something. Or, so this is less than ln of 8 over 3 divided by ln of 2. Take the 1 over, minus 1. Yep. As well as pen. 3x. Okay. Now what would I do? Well, I'm going to try and get this a little simpler here. So what am I going to do? I'm going to, let's do this. So we could say 3x. I'm going to merge these together. So I'm going to say ln. And of course you could just divide through. I mean, I guess you could just say this. But because I've done so many of these questions, I can see what they'll want. So you could just leave it like that. That's perfectly fine. There's nothing wrong with that. I mean, that's correct. But I want to get it simpler than that. So we'll do 3x is less than, I'm going to do ln of 8 over 3 divided by ln of 2 minus, now I'm going to times this by ln of 2 over ln of 2. So then I can merge these two things. So that's less than ln of 8 over 3 minus ln of 2 over ln of 2. And obviously I can divide through by 3 here. And then this, through our log rules, we can merge them. So this minus this is the same as the log of 8 over 3 divided by 2. So this will be x is less than ln of 8 over 3 divided by 2. That's from our log rules over, and the bottom 3 ln of 2 can be written as this, and this is all from your log rules to the power of 3. And so we can write our final answer. This will be what? 8 over 3. This will be 4 ln of 4 over 3 over ln of 8. And that just looks nicer than the thing I had previously. But you could have just not done that. I just, you know, I want to be kind of perfect. And that's your answer. Okay, so it looks like I've highlighted this one as well. I've also highlighted, I think I've got some integration one in there. I got a, yeah, I just highlighted some ones that look pretty juicy, pretty interesting to answer. We'll see how many we'll do. Maybe I'll do a part 2 as well. Okay, so immediately I look at this, I'm like, boom, binomial expansion. Okay, so 1 plus 3x to the negative a third. We want to expand this in ascending powers of x up to and including the term x squared. Simplify the coefficients. Well, we're going to be wanting to use our, we should probably be, hold up, let's just check. Let's check that we got that first one right. There we go, look, ln of 4 over 3 over ln of 8. Cool, so we got that. That's what we got right. Yep, so we got that right. So this is sort of how you should be doing it. If you're practicing past papers, you should have the answers next to you and then you should be checking. Okay, let's continue. So anyway, this equals to, so from our formula sheet here, on our formula sheet we have this formula, which I can't draw on. But this is the formula that we use for all binomial expansions. So we'll be using that. And because it's already in that form where this is our, so it's 1 plus, this is the equation, 1 plus x to the n equals 1 plus nx plus n minus 1, n minus 2, no, yes? What is it? That's it, right? First n minus 1, n, and then n minus 1 to the x squared plus a bunch more. Okay, so in this case, and like I explained in my exam hack video, I like to call this u, but we'll call it x here. So this will be equal to, we can write this as 1. It's already in this form of 1 plus u or x or whatever you want to call it. So this would be 1 plus nx, so our n is minus 1/3. And then x is our 3x here, like if we call that u, that's why I like to call it u. So our u here is 3x, right? So we can put the u there, so that's 3x plus now n, so minus 1/3, and then minus 1/3 minus 1 will be minus 4/3, right? Over 2 factorial times 3x squared plus a bunch more, but it says up to the x squared term, so we can keep it as that. This equals 1, that will simplify to minus x. This will be, you can just plug this in your calculator, we'll get minus 1/3 times minus 4/3 divided by 2 factorial times 3 squared, which is 9. So that's actually plus 2x squared. And obviously this goes on forever, but it says only up to and including the x squared term, so we can finish there. So we can write that as our answer. And that's it. B says state the set of values for which the expression is valid. Well, we can only ever use this expansion, this binomial expansion. We can only ever apply this formula to something like this when our u here, or they call it x, when our x, so I think this is on your formula sheet as well, is when our x, the absolute value of our x is less than 1. So when the absolute value of x is less than 1. So in this case, it'll be for when the absolute value of 3x, right? Because it's not x, it's 3x here, is less than 1. So that is the same as saying 3 of x is less than 1. Right, it's the same thing. So then you get the absolute value of x is less than 1/3. So it's only valid for these set of values. Okay, cool. I didn't highlight that one. Okay, I highlighted this one, 5. Let's check that we got that last one right. 1 minus x plus 2x squared, that's what I got, right? And then, yep, x is, absolute value of x is less than 1/3. So we got that right. Okay, let's jump into this. How's everyone? Everyone's stressing. Or else I'm, talking to myself, but that's alright. Okay, so this is a integration question. So let's do this. So we have here, we want to show that d by dx, so that this differentiated equals this. Okay? So d by dx of x minus tan inverse of x, inverse of tan. Well, this is the same as saying d by dx, because it's distributive, minus d by dx of tan inverse of x. Now we want to go to our formula sheet. Well, obviously we know what this is. This is just going to be, well, what's this differentiated in terms of x? It's just 1. And now what's this differentiated in terms of x? Well, let's go to our formula sheet here, and we can say that the inverse of tan of x, when differentiated, goes to 1/1 plus x squared. Okay, so this goes to minus, this is 1/1 plus x squared. And we want it like this, so we're going to have to merge these two somehow. So I will multiply this by 1 plus x squared over 1 plus x squared. Minus 1/1 plus x squared. Right, that's obviously 1. So now we can merge these two things together. So we get 1 plus x squared minus 1, which is just x squared on the top, and then we get 1 plus x squared on the bottom. And would you look at that? Is what we wanted. So that's what we wanted. Okay. Now it says show this. So clearly, immediately you can see, okay, somehow I'm going to have to use this result. Show that this equals this. So square root of 3, 0. So the definite integral of x tan of -1x dx. What does that equal? Well, immediately what I see is that we have two functions of x, so we're going to have to use integration by parts. So we want to grab that formula, and you'll basically know these formulas off by heart. eventually. But they are on your formula sheet, so you don't have to stress too much. So you want to be using this. So I guess I could write it out. Maybe it'll be helpful. So we have the integral of u dv. So u dv by du equals uv minus the integral of v du by, oh, not by du, by dx. By dx. Let's double check that. I'm pretty sure it's right. Du dx dx. Okay, so the only hard part here is what do we select as our u and v? As our u and dv by dx. Well, to make these selections, you have to think about what kind of integral you're going to get here, because you don't want to get another hard integral that's involving two functions of x again, because then it's just you're gonna have to reuse the integration by parts again, and that's not going to be very useful. So what we want to do here is we make an intelligent selection for u and v. So what will that be? Well, I will be selecting u as the inverse of tan x, because I can see that when I get du by dx, like I can't select, okay, if I select, let's say if I did u equals x, and then I would have to select dv by dx equal to tan negative 1 of x. Why is this a bad selection? Because then I'm going to get v equals to the integral of tan negative 1 of x dx, and I don't know how to deal with that. There's nothing on your formula sheet that knows how to deal with that, so we can't use that selection. So a better selection would be u equals to the inverse of tan of x, because then when we find du by dx, that's something that we know how to find, right? We did it here. That equals 1 over 1 plus x squared. And then our dv by dx then. So we've selected this as u, and so then that means this will be x. So that means our v will be, we're just integrating this, right? So we're going and dv equals x dx, and we're taking the integral of both sides. We get v equals x squared, a half x squared, right? Okay, so now we've made our selection. Now we can actually figure this thing out. So that means that this, so therefore we can say that this x dx equals to u times v, which is, we could say, a half x squared times the inverse of tan x, minus the integral of v, which is a half x squared, times du by dx, which is 1 over 1 plus x squared. So another reason why this is a good selection is because, okay, here now we can see, well, let's say we get a half x squared minus, we can take the half out, and we get the integral of x squared over 1 plus x squared dx. Okay? So all I've done is make this selection and then substitute it into a formula. I mean, you've been doing that since like year 9. Okay? Now, that's cool. Now, how do we deal with this? What do we do here? How do we get rid of this? Well, we can see here that we have this. X squared 1 over 1 plus x squared. It's the same as this. So let's just put this off on the side. We know that d by dx of x minus, this is from our part 1. This equals to x squared over 1 plus x squared. So that means that if we times through by dx here, and we integrate both sides, which I can do, I haven't done anything crazy, that means that x minus, it's just another way of saying integration is the opposite of differentiation, but I'm just doing it so you can see what I'm actually doing. So that equals to, because if you think about it, you know, d of anything, u, where this could be anything, this could be x squared, this could be x cubed, will always be x cubed. If this is x squared, then it'll be x squared. Yeah. So that means that this and then that equals to this. So this is just a little side note. So that we can substitute x minus tan negative 1x into here. Right? So therefore, this equals to a half x squared tan negative 1x minus a half, and we figured what this is x minus tan negative 1x from our part 1. Yep, so this is x minus tan negative 1x. Let's factor out a half. We get x squared tan inverse x minus x plus tan negative 1x. Okay, and that equals to the square root of 3, 0. Right, and we want to evaluate this because there's a definite integral between the square root of 3 and 0, because that's what it says here. So that'll equal to a half of, well, for 0, they're all going to be 0, but for square root of 3, so we'll get the square root of 3 squared is, okay, I'll just write it all out. See, the problem is I don't know what sort of level you're at. I know if I was teaching this to people who have taken my exam hack course, we could go a lot quicker through this stuff. But because I'm teaching to a wide range of levels, it's hard for me to gauge how many intermediate steps I should take. But I will take more here. So tan of inverse of square root of 3 minus square root of 3. So this is like substituting that square root of 3 in. Plus tan negative 1 of square root of 3. So that's that. Minus, then when we substitute 0, we're just going to get 0 for the first term, minus 0. And then the inverse tan of 0 is 0. And you can chuck it in your calculator if you don't believe me. Is 0, so it's going to be plus 0. So this is all 0 there. So it just comes down to a half times square root 3 squared is 3. The inverse tan of square root 3 is just basically saying, well, if theta equals, so what is this? Well, it's the same as saying what tan of theta equals the square root of 3. And honestly, with these kind of things, all I do is I just go, okay, I need this in some exact form, right? So you can then use a special triangle to figure that out, you know, with 1, 2, square root 3. You can do that. But what I actually do is, because I've seen so many of these, I just go, so I go shift tan of a square root 3. Oh, you can actually just put it in your calculator for this. So it's 60 degrees, which is the same as pi over 3, right? What I was going to say is when I get some crazy decimal, I just like, I just know what they are. So if I have like square root 2, because 1 over square root 2 is 1, is like 0.7071. I just know what that is now. So it's kind of helpful to know these important ones, like 1 over square root 2, square root 3 over 2, pi over 3. Those in decimals, they come out all the time. So anyway, so that's 3 times pi over 3 minus the square root 3 plus, this is the same thing, plus pi over 3. So you're going to get, what is this? 3 pi over 3 plus pi over 3 will give us, so it's usually helpful to keep all this stuff in fractions. So 3 pi over 3 plus pi over 3 is going to be 4 pi over 3 minus square root 3, which is going to equal, and it's always good to keep checking what we're actually trying to get here. So 2 over 3 pi minus a half square root 3. This is looking pretty promising. So that's going to be 2 over 3. A half times this is 2 over 3 pi minus a half square root 3. Would you look at that? That, my friends, is the correct answer. Cool. So all we really did there is we just used this formula, and we just figured out all you have to do for these ones is just figure out what I'm supposed to make u and what I'm supposed to make dv by dx. And that just comes down to sort of looking into the future a little bit and seeing, okay, what kind of integral am I going to get for this part? Because if you're going to get something more complex than this, then what the hell's the point of us doing integration by parts? It doesn't even help us. Okay, let's do some more. I wonder how many of these I'm going to be doing. Whoa. How zoomed in was I before? Okay, let's keep going. How many more did I highlight? I wanted to do at least like over half the paper. I'll do this one, number 7. And then I guess I'll take a piss and come back. Okay, by first expanding, so I've seen so many of these. By first expanding cos, so cos of x. So this is basically the trig identity question. Okay, so we want to express cos. So we want to express this. Express this in the form of r cos of x plus alpha, where r is greater than 0 and alpha is between 0 and 90. Give the value of r correct to 4 significant figures and alpha correct to 2 decimal places. Okay, let's do that. So first it says, it even tells you what to do first. So first we need to expand this. So let's expand that. So they give you this stuff on your formula sheet here. So cos of a plus b will equal cos a cos b minus sin a sin b. So this will become, so because of that cos of a plus b equals cos of a cos of b minus sine of a sine of b. Because of that, therefore, this becomes cos of x times cos of 45 degrees minus sine of x sine of 45 degrees, and that's that part, minus the square root of 2 sine of x. Okay, and then so what is cos of 45? Or cos of 45? And look at that, so this is, so I got 0.707 on my calculator, which I know is 1 divided by the square root of 2. And sine 45 is the same. So this is going to be 1 over the square root of 2 cos of x minus 1 over the square root of 2 sine of x minus square root 2 sine of x. So we want to combine these two things. So we get 1 over the square root of 2 cos of x minus, I'll times this by square root 2 over square root 2. So this means square root 2 over square root 2 times square root of 2 is 2 sine of x minus, oh no, why would I do that? I meant times this. Minus square root 2 times square root 2 over square root 2. So I've just times this by square root 2 over square root 2. The top is 2. And I did that so then I can merge these two fractions. So this is minus 1 over square root 2 minus 2 over square root 2 is, so we get this, minus 3 over square root 2 sine of x. Okay, so we've managed to change this into this by expanding this out and simplifying. Sorry, by expanding this out and simplifying. But what it wants it in this form here. So we have this, and we want it in this form. But remember, this is equal to, again from our formula sheet, cos of x, cos of alpha, minus sine of x, sine of alpha. Okay, and then we can keep going. So we can expand in that r. So I just expanded this part out using that formula on your formula sheet. Cos of x, cos of alpha, minus r sine of x, sine of alpha. So I'm actually going to rewrite it like this, and you'll see why I'm doing that in a minute. Cos of alpha times cos of x minus r sine of alpha times sine of x. And I'm doing that because, okay, we have it in this form. So if we want to change this into this form, then that means that this part here will equal to 1 over square root 2, and this part here will equal to 3 over square root 2. So the r and alpha, which would make it possible to put this into this form, would mean that we need r cos theta to equal 1 over square root 2, and 2, we need that r sine alpha equals 3 over square root 2. So for this to be in this form, we need these two equations to hold. So we need to just solve this. Man, they ain't giving us enough room. Okay, so how do we solve this? Well, what we do is we say we can do 2 divided by 1. This will give us r sine alpha over r cos alpha. This equals the r will cancel, and we'll get sine over. So this equals to 1 over the square root of 2. Oh no, this equals to 3 over the square root of 2 divided by. So I'm just doing this equation divided by this equation. Over 1 over the square root of 2. And I've got no room. So these r's are going to cancel with each other. And sine theta over cos theta is just tan theta. So then we have an equation. So therefore we have tan, I keep saying theta, I mean alpha. Not that it really matters because it's arbitrary. Divided by 1 over square root 2. Have I done this correct? Bum 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 bum. So we get tan alpha equals 3. So then we get shift tan of 3 is 71.56. So alpha equals 71.56 degrees, and then we can get r by substituting this back into here or here, so 1 or 2. So therefore r will equal to, so I'll substitute it into 1. So r will equal to r of cos of 71.56. This is half. That's what we wanted. Equals to 1 over square root 2. And then we rearrange for r. So cos of answer 1 over square root 2 divided by answer 2.236. How many? They wanted it to r to 4 significant figures. So that'd be 236. Okay. So yeah, I might have be a bit confused here, but literally all we were doing is just, so we just had this expression, and then we wanted to turn this expression into another form. And the way that we did that was first of all, we simplified this expression into this form. So we got it in this form. So this is exactly the same as what we started with. We just did a little manipulation. And then we said, okay, so how could we get this into this form? Well, we expanded this out and saw, look, they're of the same form, only for a certain value of r and theta will this equal 1 over square root of 2 and 3 over square root of 2, and we just found those r and theta. Okay, done. I mean, we should probably check if it's right. I'm pretty confident that it's right. I'll check after. Right, so B now. Let's do B. So now that we've shown that this can be written in this form, where r and alpha are these values, so therefore we can rewrite this as in this form, because this is the same as this when r equals 2.236 and when alpha equals 71.56. Okay, so now we can solve, and the reason we do that is because now we can actually solve it, and we need to find x values between 0 and 360. So let's divide through by 2.236, and we get 2 divided by 2.236 is 2 divided by 2.26 is 0.894, 0.894, and therefore we get x plus 71.56 degrees equals to the inverse cos of 0.894. And this has an infinite number of solutions, but the only solutions we care about is when we get x values. Our equation results in x values which are between 0 and 360. So this can equal to, if we just plug that raw value in, is 26.56 degrees, 26.56. But it will have a lot more solutions. So let's look at what those are real quick. So our cos graph looks something like this. Right, this is y, this is x. Oh my god, look at that x. X, and this is our y equals cos of x. So our first solution is, this is going to not be greatly drawn. Just pretend that isn't flat. So our first solution is here, 26.56. So that means that we're going to get a second solution. So, this is where our y equals 0.894. And we get a second solution here, and because of the symmetry, that means that this distance here will be the same as this distance here, and this is 90. So 90 minus 26.56. This is all to do with the symmetry. So 90 minus this is 63.4. So 63.4 degrees. So this is 63.4 degrees between here and here. So that means between here and here is 63.4 degrees. And because this is 270 degrees. Oh no. Oh yes, I can bring it back. This is 270, right? That means that this will be 270 plus 63.4. So we'll get another solution of this plus 270. Which is 333.4, 333.4 degrees. I guess I'll keep it to 0.44 degrees. And then we'll have a third solution. Because we're getting this minus 71.56, we're going to have to minus it to get the x value. Then we're going to need more solutions here. So what is this last one? Well, this last one is going to be equal to, this is 360, right? So this means this will be 450 degrees. So this last solution will be 450 minus 63.4, which is 386.6. So 386.6 degrees, and a bunch more, but I can see that none of those will be between our interval. So therefore, we have found that 71.56 equals to all of these, 26.56 degrees, 333.44, 0.44 degrees, and 386.6 degrees. And a bunch more. So then we minus, so we take that over and we get x equals, well, 26 minus 71, this is going to be negative, it's going to be outside 0 and 360, so we don't have to worry about that. But the 333.44 minus 71.56, that gives us, if we round up, that gives us 261.9 degrees for this one, and then 386.6 minus 71.56 is 315 degrees. I hope this is, kind of helpful, me going through some past papers. I do think this is almost sort of secondary now to doing exam analysis, and like what I do in exam hack series. This should sort of be the icing on the cake. of your preparation. Okay, let's make sure we got those right. Okay. What was it? Question 7. So 2.236 and 71.57. 2.236 and 71.556. Probably rounded that wrong. I don't think it's biggie. Yeah, I didn't round it. There we go. But it's no biggie. And the next one was 261.9 and 315. 261.9, yeah, and 315. All correct on Monday. That's a big fat tick. See, little things like that, little errors, that doesn't matter. That's not such a biggie. What's the big thing is just knowing the method. The fact that I knew how to do this before I even started the question is super advantageous for me when I'm in my exam, when I'm sitting in the room, because I've seen it a million times. I know exactly what to do before I start. I'm gonna go for a quick piss, and then maybe I'll do a couple more. Maybe I'll just do the last one. This video's already getting long, and I can probably do a part 2 some other time. Yeah, I'll do the differential equation one. Okay, let's do this one. So this is a big one that they ask. I feel like I was going too fast. This is meant to be chill. It's meant to be chill, man. I just ran off. Just math. Anyway, look, we'll do one more. It'll be around half the paper, I think. This is 10 marks. This is a pretty big question. So we'll take our time through this one. Okay. In a chemical reaction, a compound X is formed from two compounds Y and Z. The masses in grams of Y, X and Z, are X. So we've got these, so the masses, so that this is the mass of X. This compound X is equal to X, Y is equal to 10 minus X, and Z is equal to 20 minus X. Okay, respectively at any time of the formation, the of X is proportional to the product of the masses Y and Z. So we have that X is proportional to Y times Z. Present at time when t equals 0, so this is a point. When t equals 0, x equals 0, and dx by dt equals 2. Show that x and t satisfy this equation. Well, we know that the mass of x, so we know that, so it says, the rate of formation, so the rate, not this. So at any time, the rate of formation of x is proportional to the product of the mass. So we know that dx by dt is proportional to this. So dx by dt is proportional to these two, which is y and z are these values. So we have 10 minus x times 20 minus x. Right, and if something is proportional to another, if you want a solid equation from it, then you need to chuck in a constant. So this is the same as saying y equals k, which makes sense, right? If one thing is changing a little bit and it changes another variable, well, how that changes that variable is dependent on the constant. You know, if it's negative, then one will go up and one will go down. If it's small, then one will change a little and another one will change a lot. Anyway, so now we need to figure out what this k is, and we can figure out what this k is because we know that this, when x equals 0, dx by dt equals 2. So 2 equals k of 10 minus 0 is that. So that's 200. So k, therefore k will equal to 2 divided by 200, which is 0.01, which is what they have there. So therefore dx by dt equals to 0.01, 10 minus x, 20 minus x. Cool. So we proved that. And differential equations are awesome. They are trying to describe change in the external world. So they're pretty awesome. And pretty powerful. They're used a lot in engineering. So if you want to be an engineer, you should probably get these questions down. Solve the differential equation. Okay, so now it's just solving this. This is 9 marks, man. Let's go. Let's go. Okay. Well, how do we solve this? We go dx equals to 0.01. So we times over. It's important to note that we have a point here. So when t equals 0, x equals 0. Yeah. So we're just going to put that up there. So when t equals 0, x equals 0. Okay, so this, right, just times through by dt. Then I'm going to divide through by this, 10 minus x, 20 minus x. So we get 1 over 10 minus x, 20 minus x dx equals to 0.01 of dt. Okay, and I've done that, so I've got the x's with the dx and the t's. Well, we don't have any t's, but the dt separate. And that's because now when I integrate both sides, so I'm integrating both sides like this, but I can just take out the constant, so I'm just putting it in there. Okay, so this is something we know how to deal with. This is because 0.01, then we can say this is go up by a power, divide by the power, which is just t over 1, which is t. And then we got this plus c on the end, which we can't forget. And then here, how do we solve this? So let's just stop here. So 10 minus x, 20 minus x dx. So we've got down to here. So this is how far we've got. And now we need to figure out, well, how do we deal with this? We don't know how to deal with this. And the way that we deal with this is we split up this fraction into partial fractions. So we say that 1 over 10 minus x times 20 minus x equals to something over 10 minus x, some number, plus some other number over 20 minus x. And the reason that we do that is because if we can change this form into this form, we can integrate this form. So let's do that. So how do we do that? Well, we know we times through by the denominator, and I've just done so many of these, it seems kind of tedious at this point. 1 equals to a times 20 minus x plus b of 10 minus x. So 1 equals that, therefore we get 1 equal to 20a plus 10b minus ax minus bx. Let's factor out an x there. We could say, oh, we don't need to factor out x. Yeah, let's factor it out. Of minus a minus b. So therefore, because we have no x term on this, that means that this has to be, this minus a equal to 0, and this has to be equal to 1. So therefore we can set up two equations here. We can say that 20a plus 10b equals to 1, and we can say that minus a minus b equals to 0. From that we can say that a equals to minus b, and then we can substitute this into here, so we get 20 of minus b plus 10b equals 1. So that's minus 20b plus 10b is minus 10b equals 1. So b equals negative 1/10. Okay, and therefore our a will equal 1 over 10. So we have our a's and b's. So therefore, come on man, they don't even give us enough space. I guess it's because I'm not doing it on paper. Okay, anyway, so now we can change that into this. So our a is 1 over 10. And our b, so we can say minus 1 over 10. Okay, I'm going to rub all this out because we don't actually need it. Okay, so the reason that we did all of that is because we want to be able to integrate this, and now we can. So that means that this, so this over 10 minus x, 20 minus x dx, this can be written like this, 1 over 10 over 10 minus x minus 1 over 10 of 20 minus x dx. I will take out a 1 over 10 here. And this, well, this just becomes 1 over 10 times the integral. You can distribute it, so you can say the integral of 1. I'm going to take more steps here so we don't make any mistakes. Yep, same thing. And this from your formula sheet, it's on your formula sheet. Where you at, formula sheet? This comes from this. So 1 over x goes to ln of x. And you can do this by substitution if you want. So 1 over, I'm not going to, because I want to do it a bit quicker. But this will become ln of 10 minus x. And then you have to divide by this differentiated, which in this case, this inner part differentiated, which in this case is -1, minus, and then again you're getting ln of 20 minus x divided by this differentiated, which is -1. So this becomes plus, and this becomes minus. Okay, so we get 1 over 10 of ln of 20 minus x minus ln of 10 minus x. Okay, man, this is long. I guess that's why it's 9 marks. The important thing here is you don't get lost within the math. So just remember what we're trying to do. We're just trying to solve this. We're trying to get what this is, and now we found it. Now we found what it is, so we can go back to our star. So I put that star there. So now this equals this. So we can say it equals 1 over 10 of ln of 20 minus x minus ln of 10 minus x equals to 0.01 t plus c. 0.01 t plus c. Okay. You can actually merge them. So you want to start to make it look simpler, because that's way easier for us if things look simpler. So this is from our log rules. Equals to, I actually need to put brackets there. 1 over 10, 0.01 t plus c. Okay, so we've got down to this. So now we need to find this plus c, and we find that through the point that we got given, which is 0, 0. So if we plug that in, 0, 0, we get 1. So we're finding c. We plug or sub in 0, 0. So this gives us 1 over 10 of ln of 20 over 10, which is just 2, right? Because you're going to get minus 0, equals to, and that is 0c. So your c equals to this. So therefore we get an equation equal to, this is really annoying that I don't have enough space, equal to 1 over 10 ln of 20 minus x over 10 minus x. I apologize for this being a little messy. I wasn't super prepared for this video. Like I said, it's just off the cuff. Plus 1 over 10 ln of 2. Okay, so now we're down to this. Let's times through by 10. So 0.01 times 10 is 0.1. So that becomes 0.1 t. Right, that just looks a lot nicer. Oh man. Okay. Running out of room. Okay, so now we have this. Maybe I'll take it down here. So this is what we've got it to. ln of. So I mean, in theory, this is it. You've solved it, but I think it says find x equals or something. It says solve it and obtain an expression for x in terms of t. Okay, so you have to get x equals. But you have got it down into x's in terms of t, but now you need to get it down to x equals, so you just need to rearrange this. So you have it down to this equals 0.1t plus ln of 2 equals 0.1t plus ln of 2. Okay, so now what do? Well, we put these to the power of e. This is how we're going to get rid of these logs. So we do e to the power of this and e to the power of this. So we just take both sides to the power of e, which is perfectly mathematically fine. And then that means this becomes 20 minus x over 10 minus x. And this is just, and I actually have a proof on my, I think, yeah, I prove it in in the exam hack video for exponentials and logs, and also on differential equations, I think. So that becomes this, and this will, summing them is the same as saying 0.1t. So this is due to exponent rules of ln of 2, right? And this same concept here, this will become 2. So it'll be times 2, which we can put at the front. Okay, man. And then now we want to rearrange for x. So this equals 2e to the 0.1t of 10 minus x. And then we'll get, so I want to keep expanding this stuff out. So 20e to the 0.1t minus 2e to the 0 minus 2x e to the 0.1t. Correct demande. Take the x on this side, we get 2x e to the 0.1t plus, no, minus x equals 20e to the 0.1t of, so I'm taking this over, so minus 20. Okay, now we factor out here, we factor out x, so we get 2e to the 0.1t. So this is all just simplification. I'm just making sure I'm not making any mistakes. I'll factor out a 20 here to make this look nicer. So therefore we get our final answer of 20 of e to the 0.1t minus 1 over 2e to the 0.1t minus 1. So that's your answer, x equals. That's solving that differential equation. Okay, let's just check that's right. I think it'll be right. It's actually easier to do it on pen and pad, just alone. So try them yourself. Yeah, so I did get it right. So x equals 20, 0.1 e to the 0.1t minus 1 and 2. Yep, so that's right. Okay, I forgot to do, I finished that and forgot to do part C. It's just like a 1 marker. So basically what it says, state what happens when t becomes very large. What happens to x, the value of x. So what we want to do there is, you want to see what will cancel. So when t becomes extremely large, that means that, and see what I do here is I'd factor out a 2 from this and I just put it as a half. The reason I did that is because I want to cancel these things out, because when t becomes extremely large, this means that the exponential on both of these, e to the power of something very large, is something really large. So then you've got something really fucking large minus 1, and then something really fucking large minus a half, and so those are basically the same thing, and that's why I factored it out, because those will basically cancel when t becomes very large. You know, if you have a ginormous number minus 1 divided by the same ginormous number minus a half, they're basically exactly the same. So you can say that x approaches 20 over 2, which will be 10. So you say x approaches 10 when t becomes very large. I just forgot that question. Yeah, so that's it. I'm finished. Maybe I'll do a part 2 and do the rest of these questions in this new spec exam. Before right now, I'm pretty done. Don't know how long I've been shooting for, maybe like an hour or something. But yeah, I think it's been kind of relaxed. I haven't been too crazy detailed, but yeah, I just want to give you a taste of, you can do this. This is possible for you to do. It can be this easy. You don't have to struggle through this. There's a method. So yeah, if you want to know how to do this in a quick fashion, just grab my course for a minimal expense, and just don't worry about it. Sit back, relax, and listen to me, and I'll guide you towards greatness. But I'll make sure you like, make sure you sub, and yeah, I'll do a part 2 probably. But yeah, that's pretty much it. Like, subscribe, and I'll see you in the next video.